Hi everyone. First of all, I'm going to start by putting on my glasses, because I never have them on, and people don't recognize me with them on. So I'm rather humbled to be here, because believe it or not, this is the 11th time I'm at Hacktivity, and this is the first presentation I ever submitted, and it got accepted. So I'm forever grateful for the organizers. So honestly, I have so many friends sitting here in the front row that it kind of feels like a bachelor party at this point. Except my fiancée is here as well, so okay. Hacking ATMs on a budget. So those of you who don't know me, I'm a penetration tester / red team lead at Vodafone. I'm a Budapest University technology and inside that a security team alumni. I'm an alphabet soup enthusiast. I like collecting certificates. And since my job is pen testing, my biggest hobby is writing script.1 into all the possible fields on a web application. But when I'm not doing that, I enjoy woodworking, building with Legos, which I'm not ashamed of, and weightlifting, because that's cool. But you're not here to hear about me. You're here to hear about hacking ATMs. And I'm going to speak first a little bit about the journey on how this whole thing went. And one of the reasons is because one of the questions I get all the time is, hey, how do you get into hacking ATMs without going to jail? And I want to speak a little bit about that. And the second reason is that a lot of people helped me actually doing this, and a couple of thank yous are in order, and I really don't want to miss that. So yeah, story time. It all started out at my previous workplace. I used to work at Kancelár.hu, which is a small consultancy here in Budapest. And we actually offered testing ATMs as a service. We didn't have too many customers, but it gave me a taste of this whole business, and I found it fascinating. I mean, an ATM is essentially a big pile of cash protected by a computer. If that's not motivating, I don't know what is. It also combines a lot of areas of hacking. I mean, you get hardware hacking, you get software reverse engineering, malware, network hacking, all of that stuff in a single package. So I think it's fascinating, absolutely. Like all worthwhile journeys, I think, this started out with a conflict. And the conflict was that I had to write my master's thesis, and I didn't want to. And I figured the only way I'm ever going to finish this is if I pick a topic that's interesting, and I don't get tired of it. And my professor at the university, Dr. Levente Butyan, was super helpful. He actually let me pick my own topic. I mean, obviously, they couldn't provide me an actual ATM to hack. That was on me to solve. But they were fully supportive of me writing my thesis on this. So I started doing research. And to avoid getting into trouble, the way I approached this whole thing was that I started first browsing open source intelligence. So I did a lot of Google hacking. I speak very little Russian, so I browsed on Russian forums. Apparently, legislation on ATM security is a little bit different in Russia, so you have somewhat more information in Russian on ATMs than you get in English, so that was helpful. And I just tried to learn about the different attack techniques on how you can actually crack an ATM, I read a lot of articles, police reports, white papers, you name it. And by that time, I started getting a picture of all the different areas you can attack an ATM on. And it was interesting, but the problem was, obviously, to proceed, I needed access to an actual ATM. And that's where it was great that Bíró Gabriela and her colleague, Sági Csaba, who worked at the bank at the time, took me under their wings, and I actually got to test my first ATM in their bank. Unfortunately, I couldn't try everything, because this wasn't a production ATM, it was a test ATM, but I obviously couldn't rip it apart. But it finally let a little glimpse into how this whole thing works, and I could try a couple of things. And after this, I gave a really small talk to a handful of people at the Women in IT Security conference 2 years ago. And there was when I met Dr. Major Simon Béla, who is a professor at the University of Public Service. And I just finished my talk, and the whole conversation went something like this. He came up to me and he said, "Hey, I'm from law enforcement. Are you the guy who hacks ATMs?" I was like, "Yeah. We have 2 ATMs. Do you want to hack them?" Yeah. We just started doing this. And it was awesome because obviously these were decommissioned ATMs. Full disclosure, these are somewhat older models, 2006-ish. But they were still in use when I started doing this whole thing in Hungary. And I believe ATMs have a tendency to wander around from west to east. So if something gets thrown out in Germany, that usually ends up in Hungary. And what gets thrown out in Hungary usually ends up far east. So yeah, these models might still be in use, but they are officially unsupported. So I could do whatever I want with them. Obviously, we had to set some goals on what we wanted to achieve. And since I already knew the different attack categories and I had some research on how to actually do this, we set out to build a series of demos to demonstrate ATM attacks against these systems. And the purpose for this was to show forensic specialists, police officers, whatever, how actually this thing worked in the real life. So, as I said, at this point I knew quite a lot about ATMs. So we're going to start by looking at how actually an ATM is built so we can understand all the different attack vectors that you can have on an ATM. Yeah. So forgive my terrible 3D design skills, but yeah, this is what I could cook up. Obviously, everyone is familiar with this. This is the outside of an ATM, but we're going to look how it looks on the inside. So an ATM actually consists of 2 main parts. If you rip the outer cover off, which is essentially just sheet metal, nothing, it's not armored on the outside. If you go up to an ATM and knock on the side, you can feel that it really feels like a PC case, so it's just sheet metal and plastic. You have a frame which holds all the components, and actually an ATM is surprisingly modular, and all these modules are usually manufactured by different companies, so they have to have a common interface to work together. The lower half of the whole thing is called the safe area, because that's where the safe is, and the top half is called the service area. And that holds actually all the components that control the safe and the whole operation. That holds the computer, and that holds obviously all the components that are visible from the outside, the touchscreen, the pin pad, the card reader, the receipt printer, stuff like that. What you can't see on the outside, obviously, is that it has a computer, and you would be surprised. So I've seen ATMs which actually had a simple ATX IBM computer, so it's nothing special. It's not like something fancy, flashy, I don't know, industrial stuff. It's usually just a regular PC. To make matters worse, it does. I mean, you've all seen the screenshots, I suppose, of ATMs crashing. It does run Windows. These ones ran Windows XP. Newer ones are much more secure. They run Windows 7. But yeah, it's Windows. What else? So you have a really massive power supply to run all this. An ATM draws a ridiculous amount of power when it's powered on, and you usually have a hub. It's either, so it depends on the manufacturer, it's either USB or some kind of serial hub to connect all these peripherals to the computer. So, what else do you have? In the lower half, you have something that's really interesting. I mean, the safe itself is fascinating from a mechanical engineering part, but I'm not going to talk much about that. From our point of view, the most interesting component of the whole thing is the dispenser. This is like a really massive, this is an electromechanical beast of a machine housed inside the safe, and all it does is just delivers banknotes to the slot on the top. But it's fascinatingly complex. The only problem, obviously, is that it's also controlled by the computer in the top half of the ATM. So, yeah. Okay, so that's your crash course on how ATMs work. I think from this you can already deduce a couple of potential problems and potential attack vectors. I mean, as I said, obviously, you can just attack it from the outside. So, one of the most common attack methods against ATMs is the so-called skimming attack. I'm pretty sure everyone in this room heard about these. This is when they slap something over the card slot, a little gadget that records the magnetic stripe card data presented to the ATM, and then they just use this for card fraud or whatever. The next one is network attacks. These aren't that common. I mean, there was a surge, I think, a year ago, when they actually didn't attack the ATMs, but instead attacked the backend through these network connections. Sometimes these are exposed. I mean, you can see it on usually ATMs placed just on the street. But sometimes ATMs use wireless, so you don't even see this. But if you can access that, you can try your luck with that. That can yield some interesting results as well. But the actual interesting technical attack methods usually involve somehow getting into the service area. As I said, this is usually protected by weak materials, so you can just actually drill a hole into it and access the wiring. And this is what most of the attacks that are more advanced are based on. So they first drill a hole and they connect to some of the components inside the ATM. Depending on what you want to do, you can either do a malware attack, where you just plug in a USB into the control computer and install malware on that. It has to interface obviously with the ATM software and drivers and stuff there to dispense cash. Or you can do a black box attack, which is, if you look at it that way, I mean, it's kind of like a hardware malware. You plug it either on the dispenser or between the dispenser and the computer, and you just do a man-in-the-middle attack against the traffic between the computer and the dispenser. I mean, you can see on this picture, so black boxes are supposed to be small, so because you are supposed to put it in the ATM, then close it back. This on the picture, this is a Russian black box, and it's massive. So that card there, that's an ISA bus, and it's like this long. So it's a backpack-sized thing. The whole point of this is that it runs a driver that interfaces with the ATM and just sends commands to the dispenser. So this is the basic layout. So, and yeah, so malware. Malware is really interesting because you would think that all the ATM vendors write their own software, and that's true to an extent. But these malware can actually be cross-platform because the financial industry has something called the XFS protocol, and that is basically a common API that all the vendors' software have to call. And most malware target this directly. So it doesn't matter which vendor the ATM was made by. You can install the malware on it, and it's going to interface with the XFS API and just dispense cash through that. So it's kind of amazing. So I set out to try to build all of these things. I chose, first of all, I wanted to build myself a skimmer because that seemed like something from engineering perspective that could be done. Didn't look too sophisticated, to be honest. I set out to get a malware sample that I can actually run on my test ATMs and see if it works or not. So there are a lot of different samples. Some of them are really hard to get, but you're going to see, I went with a Russian sample, which was kind of advanced, so I chose that one. And I also set out to build a black box attack, which again, I thought would be interesting from an engineering perspective, but turned out to be a real nightmare. So these are the three things I'm going to talk about. So let's start. Skimming. To understand skimming, you're going to know a little bit about how this whole magnetic stripe thing works. Basically, I mean, I ran into a lot of misinformation on this topic when I researched it, because people don't really seem to realize what is actually contained on the magnetic stripe, and how you decode that. Is it encrypted, not encrypted, how it works? Yeah. So the thing is, on a physical level, the magnetic stripe has something called an NRZ, a non-return to zero encoding, and basically just stores binary data. So if you stripe it, it's just a series of chirps. You can actually use a sound card and the magnetic tape head to decode it, or yeah, in theory. The data it holds is, I mean, it depends kind of on the manufacturer, but usually it is the card number, the expiration date, and the name of the card holder. So it doesn't have the PIN code or whatever. But, and this is where most people from Hungary ask, how do you use that? Because that's usually not enough for payment, right? I mean, in Europe. Because you either use a chip and pin or tap your card or whatever. The thing is, legislation in the banking sector differs across countries. So in some countries, you can actually pay with just swiping your card and they don't ask for any code or anything. And what happens is they steal card data in Europe, then kind of export it to those countries. And you might ask, what are those countries? They must be some underdeveloped, whatever kind of countries. Yeah, so the biggest one is the USA. So in the US, you can actually just pay with swiping your card. So there you go. So yeah, this is the data you have to read. Obviously, there are some challenges because it's not really a sterile environment. You know, it's not like when you actually swipe your card. It goes through the card slot, it shakes, whatever. You can actually buy Skimmer hardware online. And as far as I observed, the price really depends on how obvious it is that it's a skimmer. So you can get a skimmer for 5,000 US dollars. You can get a portable, small form factor card reader that has advanced error correction for incorrect reads and the memory chip and Bluetooth. That goes about for $1,000 or something. But I mean, calling a skimmer a portable small factor card reader is just like, you know, calling a handgun a stainless steel bullet dispenser. So it's just, yeah. But I didn't want to do that. Reason A, I had about $100 for this whole project, and that was a little bit outside my budget. And reason B, I didn't want to get in trouble. So I just went on and designed my own. So since I was an engineering student, I approached it from engineering perspective. So I just laid out in my head, I'm going to need a magnetic tape head, I'm going to need an operational amplifier, I'm going to need an AD converter connected to a microprocessor, I'm going to need UART to connect to the Bluetooth interface, I'm going to need serial, and I'm going to write a custom application to receive all the data from the Bluetooth module. I was like, yeah, no. I mean, I had like 1 weekend for this whole project, so what I actually ended up doing was I bought a Chinese SIM card reader from eBay and slapped an Arduino on it, so tough luck. But it worked. I mentioned Bluetooth. I really wanted something with Bluetooth. The reason is because, you know, men love Bluetooth, no? I wanted it because actual skimmers nowadays have Bluetooth. And the reason for that is it reduces the risk for the attacker. I mean, you know, if you just have a memory chip on it, you have to go to the ATM, install it, wait for people to use their card, hoping it doesn't get discovered, and then go back again and, you know, retrieve it. With Bluetooth, you can just drive by, download the data, and forget about the skimmer, so that's awesome. If you go on Google Play, you can download an application called Skimmer Scanner, which is basically an app for discovering Bluetooth modules that are commonly used in skimmers. I believe it was written for the US market. They have card slots on gas pumps as well. So gas pump skimmers are really, really common. And I wanted to build something that could be detected by this application. So I chose a Bluetooth module that was common in actual skimmers. So this is my schematic. This is the Chinese SIM card reader. It is absolutely amazing from an engineering perspective. So this is a card reader that actually acts as a USB keyboard when you plug it in. So what happens if you swipe your card, it just types your card number into Notepad. So it's lovely. So I used a USB shield, connected that to the Arduino, said that the card reader was actually a keyboard, slapped on Bluetooth module, and wrote a few lines of code, and it worked. This is the housing I made. You can see my amazing craftsmanship there. I'm calling it the milk skimmer. but it actually works. This isn't a credit card, this is my gym membership card. I almost photographed my own credit card, and that would be shameful, but no. And yeah, this is the application. I mean, this is a standard USB, Bluetooth serial terminal for Android. I implemented a couple of commands. You can just dump the card data from the machine, and yeah. I mean, it's not super reliable, but for demonstration purposes, it works. Okay, let's move on. Malware. Again, first, I approached this from an engineering perspective. So I actually tried writing my malware from the bottom up, carefully reading the XFS API, reverse engineering software, whatever. But again, you know, I had a deadline. So what I ended up doing was I actually acquired a sample of the TubeKim malware. I speak a bit of Russian, but I have no idea how to pronounce this or what it means. I hope it's nothing dirty. And this is a really, really famous, I think you might have heard about this, is a really famous malware. It started its operation around 2009, but it was at its peak in 2014, I believe. And the reason why this is still around is because it's cross-platform, and it's awesome. How do you get a malware sample? So apparently you just go up to people on the internet and ask for it. So I just went up to researchers and said, hey, I need ATM malware for research purposes. She was like, are you sure this is for research purposes? I mean, yeah. And she just sent me a bunch of those. I was really happy. But yeah, you can also do it with Google hacking. And obviously, because sysadmins are people, some people just upload ATM malware to VirusTotal. So yeah. Interesting thing about TubeKim is that it's written in C#, or I mean .NET, which is awesome because you can use DNSpy. If you haven't used DNSpy before, try it. It's like one of the most amazing free software I've ever used. So you can use this to disassemble it and modify it. It has some really, really interesting mechanisms built into it, some which are standard to malware, some which is unique to ATM malware. I'm going to talk a little bit about those as well. And yeah, so the whole problem was this had to be patched in order to be suitable for demonstration purposes. And I'm just going to talk about the reasons why. So first of all, the malware has an anti-sandbox check, and not check. I mean, it's like one of the malware coding 101s to avoid sandbox. When the malware is started, you put in a delay, a sleep, and you know the sandbox just times out if it's not set up properly. Obviously, for demonstration purposes, this is not too convenient because no student is going to wait 16 hours to see a demo of an ATM malware. So I had to remove that. That was fairly trivial. Another interesting thing, the malware was set up to only run at specific intervals during the day and during the week as well. So all the cache-out operations apparently happened between 2 at night and 4 at dawn on Saturdays. So yeah, also not too convenient for demonstration purposes. I mean, I could have just set the clock on the ATM, obviously, but you know, I just thought it was more awesome to patch this out as well. There are a lot of white papers on this malware online. I mean, Kaspersky has done one, a bunch of other companies has done one, but it's usually obvious that they couldn't actually try it on a real malware, a real ATM, sorry. Because the control mappings were almost always incorrect, so I had to reverse engineer that as well. And this is messed up, honestly. So you have key codes in hex, and what I spent like 1.5 hours on, just crazily pressing buttons, is that, for example, the number 1 key on the keyboard is actually 0x2 in hex. It doesn't make sense, so yeah, that's confusing. But it is really awesome that the malware authors actually could intercept the keyboard messages from the pin pad and use that for controlling the ATM. Yeah, miscellaneous stuff. So, since this was used by organized crime, there was a pretty neat authentication process. So how they operated, from my point of view, is kind of fascinating, because what they did is they had apparently smart people in the gang and muscle in the gang. And they usually sent out people to collect the money from the ATMs, but obviously the two groups didn't trust each other. So what the smart guys did is they implemented a challenge response protocol in the malware. So when someone went out to the ATM and activated the malware, it presented a challenge code and wouldn't accept anything until a proper response was provided. So the crook at the ATM had to activate the malware, phone the guys back at HQ, hey guys, this is a challenge code, I need the response code. The guys would give him the code, and this way they would know who was withdrawing how much money at which ATM, which is awesome. Obviously, you can deduce from this that it had another software component for generating the responses based on the challenge code, and that just wasn't included with the sample. I spent quite a lot of time reverse engineering this algorithm, how this whole thing was generated. It's messed up, seriously, it's really messed up. I'm not going to present that now because I think that would be a little bit out of line, but I just ended up replacing the whole thing with the static code, so it would be easier to demo the whole thing. So, oh yeah, extra. When I first tried it, didn't work. It just started spinning the ATM and no money came out. I was like baffled. I mean, I spent like 20 hours reverse engineering, patching, whatever, what's wrong. And it turned out that the malware wanted to dispense a stack of 40 banknotes, which is like pretty thick, and my ATM just couldn't do that. So it just choked on the lot of money that it was trying to dispense. And yeah, I had to patch that as well. So, malware video, let's see. How does this work? There you go. Okay, so this is the default interface of the ATM, nothing fancy here. Apparently this one came from the UK, yeah, £8 a year. Yeah. So, first step, you go up to the ATM and you enter a cheat code. And boom, you have a cheat menu. You can actually select the cassettes from which you want to withdraw cash. And you have a challenge code here. And you see it says enter session key to proceed. So you're going to need a session key. As I said, I just replaced the whole algorithm with a static key because that was easier. It's really tedious to type because it's like 8 characters long. Boom. It's really awesome because, oh, sorry, I'm just going to rewind because it's a really, yep. As you can see, it does a couple of other things to protect itself as well. I mean, it disables the local network, and only after that does it allow the cache withdrawal to proceed. This is obviously to disable alarms and stuff like that. Okay, and you can see cache operation permitted. There you go, and yeah, just pick which cassette you want to withdraw from, which is awesome. So you just select the cassette, enter the code, and it starts working. Again, old ATM, super slow, takes a lot of time, but if we just wait patiently, then we're gonna get a stack of 4 pieces of copy paper. Yeah, that was what the ATM was filled with actually. So yeah, it works. So yeah, that was the conclusion of the malware part. I was really happy with it. I honestly didn't believe it would work, but it did. So yay. Next step, black box. As I said, first I approached this again from an engineering perspective. So I really wanted to do it on a low level and figure out how to, how this whole thing works, the communication protocol, everything. And I wanted to do a USB man-in-the-middle attack. And just hands up, guys. Who has ever tried debugging USB, actually? Yeah. I mean, I haven't before this. So those few people who raise their hands are going to know that this is a nightmare. So the USB protocol is really complex. You have device classes, different speed settings, whatever, and the cherry on top of the whole thing, that obviously Windows and Linux, they treat the USB stack differently, so whatever you try, it's not going to work. Even though I knew all this, I did try doing a USB man-in-the-middle attack, And I'm mentioning this because by doing this whole thing, I found a really amazing tool. And even though it didn't work in the end, I just want to talk a little bit about this because it might be useful for some of you if you try to ever do this. It's called the USB-Q framework. It's written by an engineer named Benoit Camredon. And I actually talked with him because the documentation was a little bit lacking. The point is this software runs on a BeagleBone Blackboard, which is, if you don't know what that is, it's kind of like a Raspberry Pi. The only difference is it has two USB interfaces, and one of them is a USB host interface, and the other one is a USB client interface. So what you can do is if you have two devices, I mean a USB device and a USB host, a PC in this case, and you want to listen on in the traffic between the two endpoints, you can just plug this thing between the two things, and you can proxy the traffic, much like, I don't know, with Burp Suite, just for USB. And I actually ended up writing a module for it, which can modify traffic on the fly using regular expressions. And so this is how the whole setup looks, nothing fancy. I tried a bunch of USB hardware. I tried intercepting USB keyboard messages, tried intercepting various game controllers, and yeah, it worked. I mean, I could do stuff like flash the, I don't know, numlock key and things like that. And at this point, I thought this would be enough because, you know, I mean, this shouldn't be so complex. I mean, the protocol itself between the PC and the dispenser. It just, you know, how many notes you want to dispense from which cassette. It shouldn't be something sophisticated. Turns out it is. I mean, when I connected my USB proxy to the ATM, there was just so much traffic on that bus that the proxy just crashed. So there was no way I'm going to do this from the ground up. And I was kind of disappointed at this point. So I tried doing Plan B. And Plan B was to reverse engineer the driver on the ATM, which communicates with the dispenser. And while reverse engineering the driver, I, you know, just did what every reverse engineer does, Googled all the strings I could find in the binary. And I found a legitimate testing tool for that model of ATM, which could be used for testing the dispenser. Now, obviously, this has security controls, so you can't just make the ATM spew out cache during the test, because that's, you know, outside operational policy. So it only works if the safe is open. Only then can you test the dispenser, which, you know, doesn't really make it useful for the attack purposes. But it turned out that someone has actually weaponized this already. They patched it, removed the security controls from the tool, and the attack is actually called Coffee Maker. You can look it up online. The only problem was I could get my hands through, I don't know, like RapidShare or some crazy site on the original legit tool. So I had the real tool, but I didn't have the modified. I didn't know the patch. And it's like, I mean, it's not an enormous binary, but it's kind of big. You can get lost in it very easily because it can be used for testing the dispenser, the printer, whatever. So it has a lot of stuff you would need to analyze if you started reverse engineering it. And yeah, but there was a rainbow. One of the researchers who analyzed this evil tool, actually released Yara rules for detecting the modified tool. And yeah, I can see a couple of people grinning. So, what happens? You have a legit tool that works. You need to write a rule that detects the evil tool that is patched. And obviously, if the Yara rule you wrote detects the legitimate tool, that's going to be a false positive, so you don't want to do it. What do? You base your Yara rule on the patch that has been applied to the legitimate tool, obviously. Now, if you do the simple math, you have the legit tool, apply a patch to it, you get the evil tool. Now, you want to make the Yara rule. You write, do you have the evil tool, the legitimate tool? You get the difference between the two, and that's your Yara rule, because that's the only way you can differentiate between the legitimate and the evil tool. Problem? Your Yara rule is going to be the patch. So, if you reverse engineer the Yara rule, which is basically just a byte string, you get the patch. And yeah, the super sophisticated modification, the patch, it's blurry on purpose, but you can see the arrows. Hands up, who finds the arrow that's missing? Or what happened? Yep. Yep, exactly. So it's like the classic when you had crack me's in the 90s to disable serial protection or something like that. You replace a jump with an op, and yeah, that's the patch basically. So yeah, based on this, I could actually modify the legitimate tool and yeah, use it as a black box. So since this thing is from 2006, everything runs on Windows XP. The driver only runs on Windows XP. The tool only runs on Windows XP. So I need a Windows XP machine, and on top of all this, it wouldn't run in a virtual machine because it needed some high-level access to the USB stack. Funny story, just a week before I did all this thing, I went to my neighbor to fix his computer, and he was like, I fixed it. He was like super grateful and said, hey, I have an old laptop, do you need that? And I was like, yeah, sure, whatever. I just tossed it in the drawer, I'm gonna do something with it later. And yeah, I ended up using this monstrosity for running the tool. So yeah, I got lucky. So this is the tool. This is the patch tool, actually. As you can see in the background, the safe of the ATM is closed, and I just have the cable plugged in inside somewhere, but the ATM itself is closed. And what you're gonna see is basically you just press a button, wait a little bit, and boom. There you go, you hacked it. And yeah, that was the basic idea behind this whole thing. Okay, as usual, I rushed a little, but I think I told you everything I wanted to. People are shy in the beginning, but just go ahead, ask questions. Usually people have a lot of questions, so I left like 10 minutes for that, so we have 4 extra minutes. Just go ahead, anyone. Gentleman there. How do you, yeah, great question. So if you go back, no, not this, not this, not this. Yeah, that. So depending on what you want to deliver to the ATM, a black box or a malware, you drill either on the bottom or the top of the ATM, because on the bottom you have cabling, which goes to the dispenser, and on the top you have the PC on the slot, and the PC has front panel USB, which is great. So what people do, yeah, exactly. So what people do is actually they use like a piece of wire or something, strap the USB cable on it, use a USB hub, plug it in. The USB hub has a flash drive, a mouse, and a keyboard, and just install the malware on it. So that's basically it. On some ATMs, you don't even have to drill because they have panels that pop up for the purpose of putting in advertisements or stuff like that. So yeah, it's nothing fancy, nothing sophisticated. Yep.
I'll bring the mic over to you.
Thank you.
So about the malware part, you mentioned the smart guys and the muscle guys. And even in this picture, it seems that the ATMs has a camera. Did the malware do something with that as well?
As I said, it disables network connection. So the camera is an interesting thing in ATMs, because if you look at a catalog for ATMs, that is listed as an extra. So not all ATMs have cameras installed, actually. And those that have cameras, not all of them are connected to the backend. Some of them just log to the disk. It didn't try to delete any files from the disk. But the thing is, so these old ATMs have cameras that have resolutions of VGA, so 640 by 480 or something like that. So you can hardly make out anything on them. And some of the ATMs are only set up not to record video, just take pictures at key moments, so it's super easy to evade it. It just takes pictures when you insert the card, you type something, and from a whole transaction you get like 3 pictures, which is, it doesn't have motion sensors or anything, so it's pretty bad.
Does anybody else have Here we have.
Just a funny one. Why didn't you use the banknotes from Monopoly?
I mean, these ATMs are fitted to do standard size cash. I mean, it varies between countries, but you have like little slides. But that's actually a nice idea, but I don't think the slides go as little as Monopoly money, but that would be cool, true.
Anybody else have a question for Marcell? No, it seems not. Then, Marcell, thank you very, very much.
Thank you very much.